Welcome to DriverDTrains. Thanks for stopping by. I'm your host, DriverD. Our conductor and brakeman, Scratchy-C, is busy inspecting the train. In August 2023, I released the first video in my series on assembling a DCC-EX command station to control our trains. A lot has changed in the intervening 2 years for both the command station hardware and the DCC-EX software. In December 2024, DCC-EX announced the release of the EX-CSB1 Express, an all-in-one plug-and-play command station and booster. This marked a major milestone in the evolution of DCC-EX from an Arduino-based project to a product that runs on a variety of modern microcontrollers. Recently, I completed a new series of videos on DCC-EX in 2025, featuring the EX-CSB1 Express and more. We learned how to configure our DCC-EX command station using EX-Installer and the Arduino IDE, and add new functions to the command station using the myhal.cpp sketch. We learned how to customize the display on our command station, added a second display to the command station, and then learned how to add additional displays using I2C multiplexers. Finally, we looked at 2 DIY alternatives to the EX-CSB1. In order to assist both new and returning viewers, I have compiled all the videos from the series into a 2-part supercut so you can have the complete set all together in 2 videos. In part 1 of the supercut, we looked at the EX-CSB1 Express, learned how to configure a DCC-EX command station using EX-Installer and the Arduino IDE, and looked at 2 DIY alternatives to the EX-CSB1. In this video, part 2 of the supercut, we'll look at how to add and customize displays on our DCC-EX command station. Further, as an introduction to these more recent videos, I have also included portions of my older video, number 4E, adding an LCD display to DCC-EX, so that viewers won't need to search out that video separately for a refresher on the basic concepts for adding displays to DCC-EX. The resulting video is quite long. To assist with navigation through the various parts, I have included a table of contents at the beginning of the video, as well as individual chapter markers in the bottom left corner of the screen. Be sure to check this video's description for links to the original videos in the series, as well as to community posts with all the websites, products, and code from the videos. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. We're cleared for the main, so notch up the throttle and let's move on out. DCC-EX in 2025. Adding displays to DCC-EX, Supercut Part 2. Here are all the loads we'll be hauling today. Introduction. Adding an LCD display to DCC-EX. Now that we've added and configured a Wi-Fi shield to our DCC-EX command station and learned how to use the WiTHrottle app to control our trains, let's add a digital LCD display to the command station. This is an extremely useful feature that lets us see the status of the command station at a glance. We'll also learn how to configure DCC-EX to add a few custom features to the display. Here are the items on today's waybill. First, we'll purchase a compatible LCD display for our Arduino Mega microcontroller. We'll also make sure we have some suitable jumper wires. Then we'll wire up and connect the LCD display to our DCC-EX command station. After that, we'll update the DCC-EX software in the Arduino IDE to make sure it is properly configured for the LCD display we're using. It's warm up here in the cab, so don't fall asleep at the throttle. This is a fast freight, so stay alert and we'll be at our destination before the coffee is cold. Adding a digital LCD display to DCC-EX. Step 1. Purchase an LCD display and jumper wires if needed. Now that we're ready to add an LCD display to our DCC-EX command station, we need to order the necessary parts. There are just 2 items we'll need to get started: the LCD display and some jumper wires. And we probably already have the wires. I'll include links for both of these items in this video's description. LCD displays come in a variety of sizes, and there are 2 sizes that DCC-EX is compatible with: a 2-line by 16-character display and a 4-line by 20-character display. We will use the 4-line by 20-character display for our command station. LCD displays also come with various types of serial interfaces, or sometimes with no interface at all. We want a display with an I2C serial interface or adapter, which is sometimes referred to as a backpack. We will need an LCD with an I2C backpack in order for our DCC-EX command station to communicate with the display. I2C, which is also written as IIC, stands for Inter-Integrated Circuit and is a 2-wire communication protocol that electronic devices can use to communicate with each other. This is also known as Two-Wired Interface, or TWI. We will often see the same LCD display advertised as being compatible with I2C, IIC, and TWI, and they all mean the same thing. We can readily find these on Amazon. I've had good luck with this GeekPi brand display I purchased in early 2023 for $11. Or if you like, you can buy 2 for $17. And yes, DCC-EX can support more than 1 display at a time, with different text on each. But that is a topic for another video. Just make sure you purchase the 20x4 version, not the 16x2, unless for some reason you only want a 2-line display. And again, make sure you buy a display with the I2C interface or backpack already attached. You can easily see the I2C adapter mounted on the back of the display. Again, I'll include a link for the display in this video's description. There is one other item to point out while we are on the subject. On one end of the interface adapter, there is a set of jumper pins. In some photos, we can see a jumper installed on these pins, while in others it is absent. These jumper pins send power to the display's backlight. When you receive your display, you will want to make sure that the jumper is installed, or else the display won't light up. I have read some reviews online of other brands that did not include the jumpers, or that instead soldered the jumper pins together. Again, I had no problems with the GeekPi brand display. The other item we will need is a package of female-to-female breadboard jumper wires. You should already have these if you purchased the ribbon cable variety pack I recommended for the Wi-Fi installation. If not, get some now. The 20cm length is a convenient size, although if you plan to locate your display somewhere away from the command station, you might decide to go with longer ones. However, the I2C protocol is only intended to cover short distances, so no guarantees how well the really long ones will work. I'll also include some links for the wires in this video's description. We now have all the items we'll need. Step 2. Connect the LCD display to the Arduino. It's now time to connect the LCD display to the Arduino Mega microcontroller at the heart of our DCC-EX command station. This is very simple to do, as long as we pay attention to the labels on the pins. First, let's make sure we unplug all the power to the command station, including the USB cable and the track power. Now, let's peel off a set of 4 female-to-female jumper wires from our ribbon cable. What we are going to do is use the wires to connect the 4 pins on the LCD display's I2C backpack adapter to the I2C channel on the Arduino. The easiest way to do this is to connect the wires to the matching I2C pins on the motor shield, which will then pass the signals through to the Arduino microcontroller. Take a look at the 4 pins on the LCD display's adapter. The GND or ground and VCC or voltage pins are for power to the LCD display, while the SDA and SCL pins are the serial data and clock pins for the I2C communications channel. Now take a look at the top of the motor shield, just next to the edge of the Wi-Fi shield, and you will see the same 4 pins. The only difference is that on the motor shield, the voltage pin is labeled plus 5V instead of VCC. We are going to use our 4 jumper wires to connect each pin on the LCD display to the identical pin on the motor shield. So we will connect the GND pin on the LCD to the GND pin on the motor shield, the VCC pin on the LCD to the plus 5V pin on the motor shield, the SDA pin on the LCD to the SDA pin on the motor shield, and the SCL pin on the LCD to the SCL pin on the motor shield. Carefully slide one end of the wire's female connectors over the pins on the LCD display and the other end over the pins on the motor shield. Here I started with the LCD first, but you may find it easier to do the motor shield first. Check the wire colors to make sure that you have connected the identical pins together. So for example, in this case, I have the blue wire on the ground pins, the green wire on the voltage pins, the yellow wire on the SDA data pins, and the orange wire on the SCL clock pins. Gently press the wire connectors all the way onto the pins and make sure they are firmly seated. And check one more time to make sure that each wire is attached to the same type of pin at each end. Go ahead and plug the USB cable back into the Arduino and let it boot. The display should light up, but you will only see a blank screen with 2 rows of boxes. We have now assembled the hardware for our LCD display. Next, let's configure DCC-EX to let it know what we have done. Step 3. Configure DCC-EX for the LCD display. Now that we have connected an LCD display to our command station, let's configure the DCC-EX code to make it work. By default, DCC-EX comes configured for a 2-line, 16-character display. We need to let it know that we have a 4-line, 20-character display. So let's open the DCC-EX sketch in the Arduino IDE, as we have done in prior videos. Using the button with the 3 dots in the tab bar at the top right corner of the window, let's open the tab with our config.h file that we copied and edited with our Wi-Fi network password in the last video. Remember, it will be down near the bottom of the menu. Now, starting from the top of the config.h file, let's scroll down past the Wi-Fi information we added in the last video and find the line that says Define LCD screen usage by the base station. In this section, we need to find the line that says #define LCD driver 0x27,16,2. You will notice that this line starts with 2 forward slashes, which means that the IDE will treat it as a comment and ignore the line when it compiles the code. So we need to start by deleting the 2 slashes. Once we do this, we should see the text change color to green and orange, just like all the other definitions in the code. Now, as I mentioned before, DCC-EX comes configured for a 2-line, 16-character display, so we need to change the code to let the command station know we have a 4-line, 20-character display. On that line that we just uncommented, we need to change the 16 to a 20 and the 2 to a 4. If we add 2 forward slashes at the end of the line, we can add a short note about what we've done. Once we've done that, we can upload the code to the Arduino using the small round upload button, just like we've done before. That's all there is to it. The command station will reboot, and we should see some basic information about DCC-EX, including its version number, power status, and free memory in the display. After a moment, a second screen will appear with the DCC-EX Wi-Fi server IP address and port number. Before we go on, let's take a moment to adjust the contrast on the LCD panel. On the backpack adapter on the back side of the display, we will find a small blue box with a screw dial in the middle of it, which is a potentiometer that we can use to adjust the contrast of the display. Use a screwdriver to adjust this based on your lighting conditions and viewing angle. You may have to experiment with it a few times to get it just right. We're off to the locomotive races. All aboard! Just a reminder that sometimes we may need to cycle the power after we update the command station in order for the Wi-Fi shield to reconnect to our network. So if you see a message in the display from DCC-EX that there is no Wi-Fi, unplug the USB cable, wait a few moments, and then plug it back in again and wait for the command station to reboot. Part 1. Customize DCC-EX Command Station Display. Now that we've learned how to use the Arduino IDE to configure our DCC-EX command station, let's look at some additional ways that we can customize the DCC-EX EX command station software. The examples we look at today will focus on how we can add additional information to our DCC-EX command station's display. Here are all the mileposts along today's route. First, we'll look at the 8 lines of text that DCC-EX EX command station normally shows on the display. Then we'll look at how to add our railroad name and a custom startup message to the display. After that, we'll learn how to add our current locomotive's speed and DCC address to the display. Finally, we'll look at how to display some useful information about our Wi-Fi in a couple of special situations. There's lots to see, so stay sharp because we're about to leave the station. Customize DCC-EX Command Station Display. 8 lines of text in EX Command Station. Before we do anything else, let's make a backup copy of our DCC-EX EX command station software. That way, if we make a typo or accidentally delete something, we can always go back to what we had before that we know works. I'll assume that you've already set up the Arduino IDE and downloaded the EX command station code like we discussed in the last video. We'll head to the Arduino folder in our Documents folder and copy or duplicate the command station EX folder. For our own reference, we'll add the EX command station version number and date to the folder name. We are now ready to edit the command station EX.INO sketch in the Arduino IDE, so we'll open that now by double-clicking on the file icon. One other thing to note is that we need to keep track of any changes that we make to the EX command station code, because when we update to a new version of DCC-EX, we will want to make those changes again. So we'll keep a log of the different sketches we work in and which line numbers we edit. I'll include a log with all the edits to the code for today's video in a post on my community page. You can find a link to the post in this video's description. Now let's get to work. By default, DCC-EX EX command station can show up to 8 lines of text on an LCD or OLED display. This is true even if our display hardware doesn't have 8 lines. DCC-EX will scroll the text on the screen if our display doesn't support all 8 lines of text. When a DCC-EX command station boots after we first plug it in, it will show on its display the DCC-EX EX command station version number along with the open source GNU General Public License under which it is made available. Once the command station is done booting, it will show up to 6 lines of additional information about its status, including its power status, free memory, and Wi-Fi information. Let's locate where DCC-EX displays each of these 8 lines in the EX command station code and see what the code for each of these 8 lines looks like. We'll start in the command station EX.INO sketch itself. If we scroll down to about line 72, we'll see a line that says void setup parentheses. The exact line number where this appears could vary depending on the version of EX command station we are using, but there will always be one line that says void setup parentheses. This is what starts running the EX command station software. Now, if we scroll down a little further to line 97 or so, we'll see a line that says display_start, followed by an open parenthesis. This is the part of the code where EX command station first starts sending information to the display. Just below this, on lines 99 and 100, we'll see 2 lines that start with LCD. LCD is the DCC-EX function to display a line of text on the screen. Even though the function is called LCD, it works with both LCD and OLED displays. Note that LCD is all in capital letters and must always be in capital letters, even if I don't say that. Just after the letters LCD is an open parenthesis. The LCD function will display the information contained within the parentheses. I won't always say LCD open parenthesis when talking about the code, but remember the parenthesis is also required. After the LCD and open parenthesis, there is a number, 0 or 1 in this case. This is the line on the LCD or OLED display where we want the text to appear. As I mentioned, by default, EX Command Station provides us with up to 8 lines of text. The 8 lines are numbered from 0 to 7. So LCD 0 is the first line of text at the top of the display, and LCD 1 is the second line down on the display, and so on, with LCD 7 being the 8th and last line at the bottom of the display. Note that if we don't use all 8 lines on the display, EX Command Station will move the text up on the display to the topmost empty line. So here are the first 2 lines of information we saw before that EX Command Station displays on the screen. The DCC-EX version number on LCD 0, which is the first line at the top of the display, and the DCC-EX General Public License information on LCD 1 just below that. The third line on the display, LCD 2, displays the command station's power status. This message originates from line 310 in the command distributor.cpp sketch. It will display either that the power is on, off, or SC. We're not going to edit this line at all, but I will explain what the messages mean because it has caused some confusion. On means that the power to both the main and programming tracks is on. Off means that they are both off, and SC means that the main and programming tracks are in different states, with the power to one on and the other off. Also, if both tracks are on and also joined with the join command, the command station will display power on join. This behavior is different from what I showed in some of my earlier videos, where the command station would display whether the main or programming track was on. DCC-EX changed the behavior in EX Command Station version 5 when they added the Track Manager functionality to the command station, which allows us to independently configure each track as either a main track, programming track, or DC track. As a result, when we have one track on and another off, the command distributor.cpp sketch that handles the display doesn't know whether it is a main track, programming track, or a DC track that is on. If we look at the command distributor.cpp sketch, we can actually see the old code that has been commented out. Unfortunately, this has caused some confusion for users, as evidenced by the questions on the DCC-EX Discord server. According to DCC-EX, the SC stands for status conflict, but in reality, there is no conflict. The message simply means that the command distributor.cpp sketch that displays the message doesn't know whether the track that is on is a main track, programming track, or neither. So if you see the power on SC message, don't worry, it is normal. Okay, let's look at LCD 3, the 4th line on the display. We'll find this back in the command station EX.INO sketch. If we scroll down a little further in the sketch to around line 140 near the end of the setup function, we'll see that DCC-EX displays the word ready on LCD 3, which we need to remember is actually the fourth line on the display. However, if we look at our command station, we won't see that on the display. That is because if we scroll down to the end of the command station EX.INO sketch, we will see on about line 207 that DCC-EX also displays the amount of free memory on LCD 3. Since this line of code runs after the line that displays ready, it will overwrite the ready message with the free memory amount. We have now looked at what DCC-EX normally displays on 4 of the 8 lines on our display. For most users, the remaining 4 lines, LCD 4 through LCD 7, will be used to display information about our Wi-Fi network. There are 2 different sketches that contain this Wi-Fi information, depending on whether we are using an Arduino-based command station or an ESP32-based command station, such as the EX-CSB1. If we have an Arduino-based command station, we can find the Wi-Fi information in the Wi-Fi interface.cpp sketch. This sketch displays either the Wi-Fi status or IP address on LCD 4 and the port number, if Wi-Fi is active, on LCD 5. We can see 2 of the status messages on line 163 and 173. Then the IP and port information on lines 370 and 374. We don't need to edit these for this video. If we have an ESP32-based command station, such as the EX-CSB1, the Wi-Fi information will be in the Wi-Fi ESP32.cpp sketch. The information displayed on ESP32-based command stations, like the EX-CSB1, varies on whether the Wi-Fi is in access point mode or station mode. You can learn more about access point and station mode in my video number 4D, Configuring DCC-EX Wi-Fi. In access point mode on an ESP32-based command station, such as the EX-CSB1, EX command station will display the Wi-Fi network name, password, and IP address on lines LCD 5 through LCD 7. Note that because nothing is displayed on LCD 4 in this situation, the command station will display those 3 lines immediately below LCD 3. We can see these LCD commands in the code on lines 267, 269, and 271. When the ESP32-based command station is connected to our home network in station mode, EX command station normally displays only the IP address on LCD 7. Again, the command station will display this line immediately below LCD 3. We can see this on line 219 in the code. In my last video, we looked at how to add some additional code to display the Wi-Fi port address as well for both access point and station mode. We'll come back to the Wi-Fi ESP32.cpp sketch again later in the video to edit which LCD lines DCC-EX displays this information on. These are the default EX command station display settings for all 8 lines of the display. There are a few other DCC-EX features that sometimes display information on the screen. For example, if an EX fast clock is connected, the fast clock time will be displayed on LCD 6. But for this video, we'll focus on the standard items that most DCC-EX users will encounter. Display our railroad name and startup message. Now let's look at some ways that we can customize the information shown on the command station's display. We'll start here in the command station EX.INO sketch. We'll start by displaying the name of our railroad or another custom message on LCD 0 at the top of the display, and then add a message on LCD 3 to show when the command station boots. We'll do this in the display start routine that begins at line 97. Let's take a moment to take a closer look at the structure or syntax of the 2 lines of code on lines 99 and 100 that show messages on the LCD or OLED display. As we discussed earlier, each of these lines starts with LCD open parenthesis followed by the line number on the screen from 0 to 7 on which we want to display our message. After the number, there is a required comma and then a capital F. The F function text macro combines everything within the next set of parentheses to display on the LCD as one bit of text. Notice that some of the text is in quotes. That means we want to display that text exactly as shown. However, note that the word version is not in quotes. That is because in the EX Command Station sketch, version is a constant, which is like a variable that never changes, that represents the DCC-EX version number. We can hover our mouse over the constant, version in this case, to see what its value is, 5.4.5 in this example. By the way, if we are ever curious about where a variable or constant is defined, we can right-click or control-click on the item in question and select Go to Definition from the pop-up menu, and the Arduino IDE will jump to the sketch and highlight the text where the item is defined. It would probably not be a shock to learn that the version constant is defined in the version.h sketch. But let's get back to our LCD functions. Note that even though there is a space between the quote symbol and the word version, when this text is shown on the LCD, there will be no space between the V and the version number. That is because the space is not inside the quotes, so it won't be printed on the display. Finally, note that each line ends with a semicolon. This is a crucial element that often gets overlooked when we are in a hurry. The Arduino IDE won't compile the code and will display an error message if we forget to include the semicolon. Now that we have a basic understanding of how to display a line of text on the screen, let's add a command to show our railroad name or other message at the top of the display, and a message to indicate that the command station is booting. We can do that here as part of the display start routine. We'll go to line 99, click our mouse, and press return to insert a new line. Then we'll add a new LCD command to display the name of our railroad or some other message on LCD 0. We'll want to make sure that we copy the format of the other LCD command lines exactly. So we'll type LCD, open parenthesis, 0, comma, capital F, open parenthesis, double quote, and then the message that we want to display, followed by a double quote, close parenthesis, and a semicolon at the end of the line. Remember that we can only display up to 20 characters on each line. We can also copy, paste, and modify another line of code if we want, which might save us some time and help ensure that we don't make any syntax errors. Next, we'll want to adjust the LCD line numbers for the DCC-EX version number and license information. To do this, we'll simply change the LCD 0 to LCD 1 on line 100 for the version number, and the LCD 1 to LCD 2 on line 101 for the license info. The command station will display the license information on LCD 2 while booting, and then display the power status on that line when the command station is ready. If we really wanted the GPL information on the display at all times, we could append it to the line with the version number. Now, let's add a message on LCD 3 that the command station is booting. Sometimes when a DCC-EX command station boots, after it shows the EX command station version number and license information, it will pause for a while, and there will be a period of time when the display freezes and nothing seems to be happening. This can occur when the command station has trouble logging onto a Wi-Fi network, or when we update the EX command station code using either the EX installer or the Arduino IDE. To help us monitor the status of the command station, both when we power it on and when we perform updates, we can display a message whenever the command station is booting, and then another message when it is ready. We saw earlier the DCC-EX displays a ready message on LCD 3 at the end of the setup process. If we display our message that the command station is booting on the same line, then once the setup function completes, it will overwrite our booting message with the word ready. So we'll display that message on LCD 3. We'll scroll to line 101 and insert a new line after the LCD 2 line that shows the license info. Then we'll add the new LCD code to display our startup message. We'll need to make sure we copy all the same syntax as before. We'll type LCD, open parenthesis, then 3 this time, comma, capital F, open parenthesis, double quote, and the message we want to display while the command station is booting, followed by a double quote, close parenthesis, semicolon. Note that there isn't enough room on the display for our message to say command station booting, but we can say CMD station booting or base station booting, so we'll try one of those. Now, when our command station boots, we'll see our startup message. Unfortunately, as we discovered earlier, we won't see the ready message because EX command station will overwrite our message and the ready message with the amount of free memory. So let's move the free memory display from LCD3 to LCD7. This will allow us to see the ready message when the command station is done booting, and we can then use LCD3 to display locomotive information in the next section of this video. We'll scroll down to line 210 now and find the line with the LCD command for the free RAM and change the LCD3 to LCD7. Now, EX command station will show the free memory information on LCD7, the last line of the display. We're almost done. We just need to make some adjustments to how the command station displays our Wi-Fi information so that the free memory doesn't overwrite the command station's IP address on the display. We did this in the last video, but we'll repeat the process again here. Note that this only applies to ESP32-based command stations. We do not need to do this for Arduino-based command stations, as the Wi-Fi interface.cpp sketch that displays the Wi-Fi information for those command stations displays the IP address and port number on LCD4 and LCD5 and does not display any Wi-Fi information on LCD7. So we'll make the following edits in the Wi-Fi ESP32.cpp sketch for both station mode and access point mode. We'll start with station mode on line 219, where we'll find the LCD command that displays the command station's IP address. By default, this is on LCD7, but we'll change it to LCD6 if we didn't already do so in the last video. Note that if we added a line to display the port information on LCD7 in the last video, we can just leave it there. EX command station will overwrite it with the free memory amount when the command station finishes booting. Now we'll scroll down and find the LCD commands for access point mode. By default, there are 3 LCD commands we need to edit. On line 267 or 268, we'll change the LCD5 to LCD4. Then 2 lines further down, we'll change the LCD6 to LCD5. And then 2 lines below that, we'll change LCD7 to LCD6. Again, this is exactly what we did in the last video. And if we added a line to display the port information on LCD7, we can just leave it there as well. After we've made all these changes, we can instruct the Arduino IDE to verify the code to make sure there are no typos or missing semicolons, and then upload it to our command station using the round buttons at the top left corner of the IDE window. After the upload is complete, our command station will reboot, and now we'll see the name of our railroad or other message that we added at the top of the screen, along with a message to let us know that the command station is booting. Then, when the command station is done booting, we'll see a message that it is ready. And we'll still see the DCC-EX version number, track power status, command station status, all the relevant Wi-Fi information, and the free memory on the display. All aboard! Now let's see what else we can do. Display our current locomotive's speed and address. Let's customize our command station to display the current locomotive's DCC address and speed on the display. We can display this information on LCD3, the 4th line on the display, where we put our base station booting message, which says ready after the command station boots. This assumes that we moved the free memory display to LCD7, as we just discussed. To display this information, we'll edit the command-distributor.cpp sketch. This is the part of the EX command station code that receives inputs from our Wi-Fi throttles, such as YThrottle and engine driver, and then forwards the commands to DCC-EX while sending messages back through its own YThrottle server. If we scroll through the code, we'll see a number of different spots where the command-distributor.cpp sketch broadcasts various types of information, including information about sensors, turnouts, turntables, and clock time. Eventually, at line 210, we will see the start of the bit of code where it broadcasts information about our locomotives. Line 212 has the details we need for the locomotive's address and speed. We are going to incorporate these into an LCD command on line 213, so we'll click our mouse in front of where it says #ifdef_sabertooth and press return. However, we are also going to need to do some math. Let's take a look. Here is what the basic command looks like. LCD3F loco $D speed $D, SP loco SP speed code. The two $Ds inside the quotes tell the F text function macro to include the decimal values of the two variables listed after the quotes in the text string we send to the LCD. Those two variables, SP loco and SP speed code, are part of a larger speed table that also includes the status of the locomotive's throttle functions. So this command displays the text loco with the locomotive's DCC address, followed by the text SPD and then the locomotive's speed. There's only one problem. If we upload this sketch to the command station and try it out, we will see that although our locomotive's ID looks fine, the speed does not match what is on our throttle. For example, if our throttle is set to speed step 1, the command station will display 130, and if the speed is set to 126, the command station will display 255. However, if the throttle is set to -1, the command station will display 2, and with the throttle at -126, the display will show a speed of 127. Even more strange, if we set the throttle to idle while moving forward, the display will indicate speed 128. But if we set the throttle to idle while moving in reverse, the display will indicate 0. Finally, if we issue an emergency stop command, the command station will display speed step 129 if the locomotive was going forward, or speed step 1 if it was in reverse. Note that while I have shown these examples using the switching or shunting throttle, the results are the same when using a traditional throttle. The reason for this is that the locomotive throttle speed is represented by a number from 0 to 255, but not in one continuous line. Rather, the speeds are represented by two separate columns of 128 numbers each, one for forward and one for reverse, with the forward column of numbers stacked on top of the reverse column. Then, just to mix things up a little more, there are two separate speeds for idle, 0 and 128, and then immediately after those are two separate speeds, 1 and 129, for emergency stop. Are you confused yet? I know I am. So we need to do some math to make sense of the speeds in the internal speed table before we display them on the screen. And the exact math we do depends on whether the locomotive is moving forward or in reverse. Here's a short summary. If the speed table indicates that the locomotive speed is either 0, 1, 128, or 129, we want to show 0 on the display. If the speed is greater than 129, we want to subtract 129 from the speed. Otherwise, if the speed is less than 128, but not 0 or 1, we want to display the speed as a negative number by subtracting the speed in the speed table from 1. So we will create some if statements for those three scenarios, and then modify our LCD command accordingly. This is what the finished code looks like. Again, you can get a copy of the code from a community post on my channel that I will link to in this video's description. Now, when we upload our sketch and run our locomotive, we will see the speed displayed from -126 in reverse to +126 forward speed. The display will update anytime we change the locomotive speed or issue a function command. If we change to another locomotive, its speed will be shown on the display. In my next video, we'll look at how to add a second display to our DCC-EX command station to show the speeds for even more locomotives. Custom Wi-Fi messages for special situations. Before we wrap up for the day, let's take a quick look at two examples of special situations when we might want to show information about our Wi-Fi password on the display. I won't go into all the details here in the video, but you can find all the edits to the EX Command Station code in a community post on my channel if you think these situations might apply to you, or if you're just interested. The first situation arises when the command station boots up in access point mode, even though we have configured it with our station mode password. As we discussed earlier, the Wi-Fi on a DCC-EX command station can run in one of two modes, access point and station mode. Normally, we choose which mode we want the command station to run in. However, as I described in my video number 4D, Configuring DCC-EX Wi-Fi, sometimes the command station will boot into access point mode even though we've configured it for station mode. This will occur when the command station is unable to sign on to our Wi-Fi network. This could happen because our home Wi-Fi router is not working, or because we've taken our DCC-EX command station to use at another location where it can't reach our network router. This could be in a basement, outdoors in the yard, or on a trip around the world. In any case, when this happens, the command station will boot in access point mode, but with our station mode home network password. So in order to use the command station in these situations, we will need to connect our phone or tablet's Wi-Fi to its access point network as shown on the display, but using our home Wi-Fi password, which of course is not shown on the display. This can cause some confusion as we may not remember that we need to do this. To alleviate this confusion, we can display a generic message to remind us to use our home network Wi-Fi password when the command station boots in access point mode while configured for station mode. The other unusual situation that might come up is when we want to configure our DCC-EX command station to use on a public Wi-Fi network and want to show the Wi-Fi name and password on the display. This could occur if we are configuring our command station to use on a club layout, for example, or with a dedicated Wi-Fi network router that we only use for our layout and DCC-EX. By default, EX Command Station will display the Wi-Fi network name and password in access point mode, at least on an ESP32-based command station, but not in station mode. However, we can have that information displayed in station mode as well. Again, I will include all the necessary code to do this in a post on my community page. But we've just passed the last milepost and our destination is in sight. So we'll call it a day and celebrate our accomplishments as we wait to see what tomorrow brings. Part 2. Add a second display to our DCC-EX command station. Now that we've learned how to use the Arduino IDE to customize our DCC-EX command station's display, let's look at how to add a second display to our DCC-EX command station. For this discussion, I will assume that you already have one display attached to your command station, either because you added it yourself or because you purchased an EX-CSB1 with a display included. At several points during this video, I will refer you to my prior video, number 4E, adding an LCD display to DCC-EX, as well as the previous videos in this series if you need additional information on how to connect and customize your display. Here are all the messages on today's train board. First, we'll start with the hardware by looking at the different types of displays we can use, how we can set the hardware addresses for those displays, and connect them to our DCC-EX command station. Then we'll update the EX Command Station software to confirm our new display's address, configure the display, and then look at some ways we can put our new display to use. We've got our orders, so notch up the throttle, release the brakes, and we'll move on out. Add a second display to our DCC-EX command station. Preparing the hardware. Part 1. Display options, LCD and OLED. Let's start by looking at some of the different types of displays that we can connect to our DCC-EX command station. For this discussion, I will assume that your command station already has one display. If not, be sure to check out my video number 4E, adding an LCD display to DCC-EX. The DCC-EX EX Command Station software supports two broad categories of display screens. These are LCD character-based displays and small OLED displays that can be used as character-based displays with a suitable graphics library. These types of displays typically support from 2 to 8 lines of text. LCD and OLED displays come in multiple sizes, both in terms of their physical dimensions as well as the number of characters or lines of text that they can display. The LCD screens that DCC-EX supports come in two sizes. The smaller screens can display 2 lines of text at a time, with up to 16 characters on each line. The larger LCD display screens can display 4 lines of text at once, with up to 20 characters on each line. OLED displays come in a wider variety of shapes and sizes. The typical OLED displays that DCC-EX supports range in size from just under 1 inch to about 1.3 inches across. These displays have a nominal resolution of 128 by 64 pixels, although some displays use a driver chip called an SH1106 that has an actual resolution of 132 by 64 pixels. These are the displays that DCC-EX is currently using with the EX-CSB1. There are also 2.4-inch versions of the OLED displays that also have a nominal resolution of 128 by 64 pixels, although again, some have an actual resolution of 132 by 64. These are much larger in physical size and easier to read from a distance than a 1 or 1.3-inch display. Note, however, that most 2.4-inch displays use an interface called SPI that is not compatible with DCC-EX. We need to make sure that we find a version that is pre-configured for the I2C interface, as we'll discuss in a moment. Some displays claim to work on both SPI and I2C. They do not, without considerable modification. I'll include a link to the correct version of the 2.4-inch display, as well as some of the smaller displays in this video's description. Note that OLED displays require us to solder header pins to the board before we can use them. The displays come with straight pins, but we can also purchase 90-degree angled pins if we prefer those. All of these OLED displays support up to 8 lines of text, with 20 characters on each line. The difference is that the text characters appear larger on the larger screens, although not as sharp up close. There are also half-height versions of the 1-inch screens that have a 128 by 32 pixel resolution and support up to 4 lines of text. Both LCD and OLED displays are also available with the display text in different colors. Common colors include white, blue, green, yellow, and red. Most LCDs have white text, but some are also available with black text and with different color backlights. I'll include links to some of the displays that I have tried in this video's description. Part 2. The I2C interface and I2C addresses. All of the displays that DCC-EX supports need to have an I2C interface. Also called I2C or IIC, the Integrated Circuit Interface is a popular 2-wire serial communications protocol for connecting peripherals to processors and microcontrollers. As its name suggests, the I2C interface uses 2 wires for serial communications, a data line abbreviated SDA, and a clock line called SCL. However, I2C devices also need to have power and share a common ground, so I2C connections typically use 4 wires: power or voltage called VCC, ground or GND, the data line SDA, and the clock line SCL. You can learn more about the I2C interface in my video number 4E, Adding an LCD Display to DCC-EX. All I2C interfaces used with any specific controller, such as our DCC-EX command station, are connected to that device in parallel on the same communications bus using the same data and clock lines. That means we can piggyback I2C devices together or daisy chain one I2C device after another. However, in order for our controller to be able to communicate with any specific I2C device, each device must have its own unique I2C address. We'll discuss how to figure out what a device's I2C address is and change the address later in this video. There is a narrow exception to the unique address rule for displays. Because displays only receive information and don't communicate back to the controller, Multiple displays of the same type with the same screen resolution can coexist on the same I2C bus. They'll just show the same message on each display. For our DCC-EX command station, this can come in handy if we want to show our command station's status and Wi-Fi information or any other information on multiple displays spread around our layout. However, if we want to show different information on each display, we need to change the I2C address on at least one of our displays. This involves soldering across some jumper pads on the display. The exact way that we change the I2C address for each display depends on the display. LCD displays are generally easier to work with in this regard. Many LCD displays have an I2C backpack that has a series of 3 solder pads, typically labeled A0, A1, and A2, that allow us to change the I2C address to one of 7 additional addresses. For example, the default I2C address for many 20-character, 4-line LCD displays is hexadecimal address 27, which is written as 0x27, and this is the I2C address listed in the EX command station config.example.h sketch. However, if we solder across the A0 pad on the backpack, the I2C address will decrease by 1 to 0x26. If we then soldered across the A1 pad, the address would decrease by 2 more to 0x24. We can use combinations of the 3 solder pads to change the LCD's default I2C address from 0x27 to anything between 0x20 and 0x26. Unfortunately, OLED displays do not offer as many address options. Most OLED displays offer 2 address choices that can be selected by moving a 0-ohm resistor from one solder pad to another. The exact location and configuration of the resistor varies from manufacturer to manufacturer, and not all displays include one. I've had trouble working with the tiny resistors, which resulted in poor connections, but we can do away with the resistor and just solder across the pads with a small bit of wire if necessary. The default I2C address for many OLED displays is 0x3C, with the optional address being 0x3D. These are equivalent to 60 and 61 in decimal form. However, most of these OLED screens will have 0x78 and 0x7A printed on the boards. These are equivalent to 120 and 122 in decimal form. The reason for the discrepancy is that the I2C hardware designers bit shift the 7-bit address in an 8-bit byte, which effectively multiplies the address by 2. But the coders of the Arduino software libraries that we use to communicate with I2C devices use the unshifted address. So we will need to use the unshifted 0x3C or 0x3D address when we configure our OLED displays later in this video. Because OLED displays typically offer only 2 I2C address options, it means that we can only add 1 additional display to our DCC-EX command station's I2C bus, unless we want to add a display that mirrors another one. In my next video, we will look at how to get around this limitation by adding an additional piece of hardware to our communications bus known as an I2C multiplexer. As I mentioned previously, for LCD displays, we can choose up to 7 additional addresses to use. However, we can't easily use LCD displays with the EX-CSB1 because most LCDs require 5 volts on the I2C bus to work, and the EX-CSB1 is only rated for 3.3 volts for I2C. Again, there are ways around this limitation that we'll explore in a future video. But for now, for the EX-CSB1, we'll want to stick with OLED displays, which typically work on both 3.3 and 5 volts. We'll consider some more of the particulars of the I2C bus next. Part 3. Connecting our display to the I2C bus. To connect our second display to our DCC-EX command station, we connect it to the command station's I2C bus. There are several ways to do this, depending on which command station we are using. In my video number 4E, Adding an LCD Display to DCC-EX, we looked at how to connect our display to the I2C pins on the motor shield. There are actually 2 sets of I2C pins on the motor shield, so we can easily add a second display directly to these pins. There are also I2C pins in the GPIO headers of the Arduino itself. On the EX-CSB1, there are also a number of different locations where we can connect to the I2C bus. There are two sets of I2C pins next to the I2C header for the built-in display, although the display partially covers them. There are also I2C pins in the GPIO headers on the board that match those on the Arduino. And finally, the EX-CSB1 also features a Stemma Quick I2C connector, which is based on one of the smallest members of the JST, Japanese Solderless Terminal, family of connectors. We can purchase special cables with the Stemma Quick plug on them to connect our displays. One important thing to note is that, except in the case of the Stemma Quick connector, there is no standard for the order or arrangement of the I2C pins. In other words, the pins will be in a different order on different displays and different command stations and motor shields. For example, on some displays, the order might be ground, VCC, SDA data, and SCL clock, while on other displays it might be ground, VCC, clock, and data. The header for the OLED display on the EX-CSB1 has this latter arrangement. However, the two rows of I2C pins just next to the OLED header are ordered SCL clock, ground, SDA data, and VCC, so go figure. The order of the pins in the Stemma Quick connectors is standardized, as are the colors of the wires in the cables, with black being the ground, red the VCC, blue the SDA data, and yellow being the SCL clock line, in that order. I always remember that yellow is the SCL clock line on the Stemma Quick connector because yellow has two L's in it, so it goes on the SCL pin of the display. We need to make sure that we pay very close attention to which pins are which when we connect our I2C cables, because the odds are that the pins will be in a different order on each end of the cable. It is very common to mix up the clock and data lines. Although this won't ruin the display, it also won't work that way. Another factor that we need to consider and pay attention to is the operating voltage of the command station and what kind of displays are compatible with that voltage. Traditional Arduino microcontrollers and compatible clones run on 5 volts, so we can use either LCD or OLED displays with DCC-EX command stations based on those controllers. ESP32-based command stations, however, such as the EX-CSB1, run only on 3.3 volts, so we can't normally use 5-volt LCDs with them. There are ways to get around this limitation with additional hardware to level shift the voltage, but that is beyond the scope of this video. So for the EX-CSB1, or most other ESP32-based command stations, we want to stick with OLED displays, which work on both 3.3 and 5 volts. Something else to consider when attaching our displays to the I2C bus is what kind of cables to use. While we can use breadboard jumper wires, such as those I described in my video series on assembling a DCC-EX command station, or the small Stemma connectors to connect our displays to the command station, we don't have to use those and might prefer something more robust that we can use over a longer distance. One convenient option is to use computer Ethernet cables. We can easily connect an inexpensive RJ45 Ethernet jack breakout board with pin headers on it to our command station, and then run an Ethernet cable of whatever length we like to another RJ45 jack that we can attach to our display. And since the RJ45 actually has 8 wires in it, we can conceivably use it for more than just the I2C bus, or more than just one display. Finally, while there aren't any I2C splitter cables that I'm aware of, there are inexpensive I2C breakout boards that we can use to connect up to 7 additional I2C devices to our I2C bus. And we can use any or all of these connection strategies together. So for example, we could use a Stemma Quick connector or other jumper wires to connect an RJ45 jack to our I2C bus, then run an Ethernet cable to another RJ45 jack, attach that to an I2C breakout board, and then attach additional displays to that. And by using some displays with the same I2C address, we can have important or useful information from our command station available at multiple locations around the layout. We have now looked at the basic hardware considerations for adding a second display to our DCC-EX command station, including the different types of displays available, how to change their I2C addresses, and how to connect them to our command stations. Now let's look at how we can configure the DCC-EX EX Command Station software to use our additional displays. Update the EX Command Station software. Part 4. Confirm our display's I2C address with I2C scanner. Now that we've connected our new display to our command station, let's configure the DCC-EX EX Command Station software to recognize it and look at how we can use it. The first thing that we will want to do is confirm our new display's I2C address and that it is connected and visible to the command station. We can use DCC-EX for this. First, however, I will mention that there are also sketches that are designed specifically for identifying I2C devices connected to our I2C bus, and both the Arduino and ESP32 code libraries include examples that we can use in the Arduino IDE. We can find these in the File, Examples, Wire menu. There are numerous other variations of the sketch with different names available from other sources, but they all do the same thing and any of them would work. We just need to make sure that the serial communication speed specified in the code matches the baud rate setting for the serial monitor in the IDE. However, we don't need to use any of those sketches because the EX Command Station software already includes and runs the necessary code at startup. The specialized task-specific sketches I mentioned previously can be helpful if we are troubleshooting several I2C devices at once or making a number of modifications to our hardware setup. But for most situations, we can simply use DCC-EX. As I mentioned, DCC-EX will run the I2C scanner code at startup and send the results to the command station microcontroller's serial output. We can view this output in one of many different places, including the IDE serial monitor, the EX installer device monitor, the EX web throttle debug console, and the JMRI DCC++ traffic monitor. Unfortunately, in many cases, the DCC-EX I2C scanner code runs before we are able to establish a serial connection to our command station, so we may not see the EX command station I2C scanner's results. However, we can easily reboot the command station by entering open angle brackets, capital D, reset, close angle brackets on the command line in the Arduino IDE or EX installer, or simply capital D reset without the angle brackets in JMRI or the EX web throttle app, and then pressing return or enter. Our command station will restart and we'll see the I2C scanner results in the output window, including the I2C address of our original display, as well as the I2C address for the new display we just added. Part 5. Configure our new display in EX Command Station. HAL Setup. Now let's configure the EX Command Station software to use our new display. To do this, we are going to add a new sketch to the Command Station EX code called myhal.cpp. HAL stands for Hardware Abstraction Layer, and it provides an interface between the software and the hardware so that our software, EX Command Station in this case, will work as expected regardless of what hardware we are using. We can create this new myhal.cpp sketch in the Arduino IDE, or by creating a new plain text file in the myEX-installer folder where we stored our EX-installer configuration files in video number 8B, Configure DCC-EX EX-CSB1 with EX-installer. While we could add the new display configuration in our myautomation.h sketch, we are going to use the myhal.cpp sketch for other things in this video, so we'll configure the new display here as well. Note that, for the purposes of this video, I will be showing the myhal.cpp sketch in the Arduino IDE, but we could just as easily write all the code in the EX-installer app and save it in our myEX-installer folder. We'll create the new sketch or text file, then enter the following code. Hashtag include, quotes, io_haldisplay.h, end quotes. This will allow us to add new displays to our hardware abstraction layer. Remember, all the capital and lowercase letters and punctuation need to appear exactly as shown. I will include all the code from today's video in a community post on my channel. Next, we'll create and configure our new display in the sketch. We'll do this by adding a HAL-setup function as follows. Void HAL-setup parentheses open curly brackets. Then we'll create and configure the display. We can do this for both LCD and OLED displays. For each display, we'll need to assign it a number. The original default display that we defined in our config.h sketch is display number 0. The additional displays we define in the myhal.cpp sketch start at number 1. For example, for a 20-character, 4-line LCD display with an I2C address of 0x26 that we want to be screen number 1, we would write the following. HAL display, open angle brackets, liquid crystal, close angle brackets, colon, create, open parentheses, 1, 0x26, 20, 4, close parenthesis, semicolon. For an OLED display as screen number 2 with an I2C address of 0x3D and a 132 by 64 resolution, we would write HAL display, open angle brackets, OLED, close angle brackets, colon, create, open parentheses, 2, 0x3D, 132, 64, close parenthesis, semicolon. Note that we didn't have to choose screens 1 and 2 for these examples. In theory, we could have chosen any numbers from 1 to 254 for either display, although for some reason EX-Rail automations do not seem to work with anything above 242. We can also create software definitions for the displays here in the hardware abstraction layer, even if those displays don't exist. The code doesn't care. Once we are done creating our display, we end the HAL-setup function with a closed curly bracket. Part 6. Using our new display and EX command station. The screen command. Now that we have created our new display in the EX command station code, we want to use it. To do this, we use the DCC-EX screen command. The screen command works just like the LCD command we used in the last video, except that we indicate which screen number we want to display our text on, along with which line number. There are 2 ways we can use the screen command: in our EX-Rail automations and in the EX command station code itself. For example, in our myautomation.h sketch, either in the Arduino IDE or in EX-Installer, we can add the following line of script to the auto-start sequence for the LCD screen we defined earlier, or this line for the OLED screen. Then we can upload our sketch to the command station, and when it reboots, we should see the Hello World message on our new display. We can now use the screen command in any of our EX-Rail scripts to show messages on our new display. We can also use the screen command in the EX command station code in the Arduino IDE, the way that we used the LCD command in the last video. We just need to add which screen number we want to display our text on. And remember, just like with the LCD command, we need to use the ftext function macro for the text we want to display. So for example, suppose that instead of displaying our command station's Wi-Fi information on lines 4 through 7 of the main display screen, we wanted to display that information on lines 0 to 3 of our new display. To do that, we would change the LCD commands in the Wi-Fi interface.cpp and the Wi-Fi ESP32.cpp sketches to be screen commands. Add the screen number that we configured in our myhal.cpp sketch for our new display to the command just before the line number, and then change the line numbers 4 to 7 to be 0 to 3 accordingly. Now, the first 4 lines of information that EX command station displays, including the version number, power status, and free memory, will be on our original display, while the Wi-Fi information will be on our new second display. We can also use screen commands in our EX-Rail automations and the EX command station code together. By adding screen commands in our myautomation.h sketch or other automations, and using screen commands in the EX command station code, we can configure our new displays just the way we like. One thing to note is that any displays we might add that have fewer than 8 lines will not scroll from page to page to show all the lines of text if there are more than the display will show at once. Also, the individual lines will not move up the display to fill in any blank lines the way they do on the default display. Display information about our locomotives. Now let's look at an example of how we can use our new display to show information about our locomotives. To do this, we will add some code to the myhow.cpp sketch to create a new function that will show the information we want to display about our locomotives, and then add a user add-in to the howSetup function where we created our new display. Here's what that code looks like. The code is based on a sample provided by DCC-EX in the myhow.cpp_example.txt file. The code must appear above and not inside the howSetup function. Again, I will include all the code in a post on my channel community page. This code creates the updateLocoScreen function, which uses the same locomotive speed table information that we used in the example from the last video to display information about our locomotive on our main screen. In order to include information from the DCC locomotive speed table in the updateLocoScreen function, we need to include the DCC.h sketch here in myhow.cpp, which we'll do with a #include statement. The updateLocoScreen function will display information for up to 7 locomotives on whichever screen we select, in this case the OLED that we created as Screen 2. You may notice that this version of the code uses binary math to convert the speed from 0 to 255 to 0 to 127 forward or reverse, which is more efficient and eliminates the need for the if statements from my last video, although a bit harder to decipher. Now, to actually call or run or execute this updateLocoScreen function, we create a user add-in in the howSetup function. So in the howSetup function, just below where we created our new display, we'll add the following command: user add-in : create, open parenthesis, updateLocoScreen, 1000, close parenthesis, semicolon. What this does is tell the EX Command Station software to call our updateLocoScreen function to display information about our locomotives on our new screen every 1000 milliseconds, which is to say, once per second. Now, if we upload our code to the command station, when it reboots, we will see the title Active Locos on our new display, and when we select a locomotive from the throttle, we will see its speed and direction shown on the screen. We can select more locomotives and their information will be added to the list, with up to 7 in all. However, if we run this code on a 4-line LCD screen, we will see that only information about the first 3 locomotives is shown, and the screen doesn't scroll to display information about the other 4. Instead, information about the last locomotive overwrites the bottom line of the display. That is because the screen command executes a different set of code than the LCD command, and they are not exactly the same. As a result, as I mentioned before, our second display, or any others that we might add, will not scroll to show additional lines when we use the screen command. However, we can implement our own scrolling code to show not just 7 locomotives, but as many as we are able to run in DCC-EX, and the display will scroll through the entire list, then cycle back to the beginning. Here is that updated version of the code and how it looks in action. Again, I'll also include this code in the post on my community page. A fun startup animation. Finally, how about we have some fun by displaying a startup animation whenever the command station boots? We could also create EX rail automations to display an animation like this when a train reaches the station, when a signal clears, or just randomly from time to time. Again, you can find the code for this animation in a community post on my channel. Part 3. Add a display to DCC-EX using an I2C multiplexer. Now that we've learned how to add a second display to our DCC-EX command station, let's add more using an I2C multiplexer. For this discussion, I will assume that you already have one or more displays attached to your DCC-EX command station and are familiar with how to add additional I2C displays to the command station. If not, be sure to watch the prior video number 8E, Add a second display to our DCC-EX command station. Here is our switch list for today. For this video, we'll start with the basic question of what is a multiplexer, and look at two different types of I2C multiplexers that we might want to use with DCC-EX. Then we'll look at how to set the multiplexer's I2C address, connect it to our command station, and connect displays to the multiplexer. After that, we'll look at how to edit the DCC-EX EX command station code to create a display connected to the multiplexer, and then use the display to show information about our trains. We're switching it up today, so let's get started. Add a display to DCC-EX using an I2C multiplexer. What is a multiplexer? In the last video, we learned how to connect additional I2C displays to our DCC-EX command station. We also learned that generally speaking, every I2C device must have its own I2C address. However, we also discovered that most OLED displays only offer two choices for their I2C address, and some only offer one. While LED displays typically offer 8 addresses to choose from, both LED and OLED displays require some tricky soldering to change their I2C addresses. We can get around these limitations and complications by using an I2C multiplexer. A multiplexer, or MUX for short, is an electronic selector switch which allows us to connect a single device on one side of the switch to multiple devices on the other side of the switch, and then select which of those devices we want to use at any given time. We can think of a multiplexer as a kind of electronic telephone switchboard that allows a device, our DCC-EX command station in this case, to place calls to other devices connected to it. In our case, we will use an I2C multiplexer, which will allow us to connect our command station's I2C bus to several other I2C buses connected to the multiplexer, each of which could have one or more devices connected to it. In the last video, we talked about some of the limitations of having multiple devices with the same I2C address on a single I2C bus. Essentially, the I2C bus is like an old-fashioned telephone party line, with everyone sharing the same service. An I2C multiplexer allows each device to have its own private line. The advantage to this is that we can use multiple I2C devices with the same I2C address, and as long as they each have their own connection to the multiplexer, they will all work independently. For our displays, this means that we can use multiple displays with the same I2C address and show different information on each display. An I2C multiplexer will work with any I2C devices, including I2C sensors, turnout and servo controllers, GPIO expanders, and more. But for today's video, we will focus on using an I2C multiplexer to add additional displays to our DCC-EX command station. Types of I2C multiplexers. Generally speaking, most I2C multiplexers commonly found in the maker community are based on the same family of chips from Texas Instruments. This family includes the TCA-9548A and PCA-9548A 8-channel multiplexers, and the TCA-9544A and 46A, and PCA-9544A and 46A 4-channel multiplexers. They all work the same for our purposes. The only difference between the TCA and PCA versions is that the TCA chips can run at a lower voltage than the PCA chips, but our command stations run at higher voltages, so that doesn't matter. DCC-EX is generally compatible with any multiplexers that use these chips or their equivalent. It is actually possible to purchase the bare multiplexer chips, but we will look at the available options for pre-assembled breakout boards that feature these chips along with pull-up resistors and pin headers or connectors. The first option is to purchase a standard breakout board with pin headers. These are sold by countless vendors, but all look the same and are probably based on the Adafruit design from 2015. We can purchase these for about $1 each in bulk, or can buy 5 for the same price as one. If we look carefully on Amazon, we can even find a helpful review. One thing to note about the breakout boards is that, as with the OLED displays we looked at in the last video, we need to solder on our own pin headers if we want to use jumper wires to connect them, or else solder our wire connections directly to the boards. Also, the breakout boards only route the I2C SDA data and SCL clock lines through the board, not the ground and VCC lines. We will need to wire those up to our I2C displays or other devices separately. The other option is to use an Adafruit Stemma Quick I2C multiplexer, which mounts the I2C chip on a breakout board fitted with Stemma QT quick connectors. These are more expensive than the basic breakout boards, but don't require any soldering on the multiplexer if we use Stemma Quick cables. The other nice thing about these boards is that they route the ground and VCC through the boards to the Stemma Quick cables, so we don't need to wire those up separately. The Adafruit Stemma Quick multiplexers are available in 2 sizes, one with 4 connections, which comes in a very compact package, and one with 8 connections. The 8-channel board also features a 3.3 volt voltage regulator, which can be handy if we want to connect 3.3 volt I2C devices to our 5 volt Arduinos. In addition to Adafruit, SparkFun also makes an 8-channel I2C multiplexer with quick connectors. One unique feature of this board is that it features 2 quick connectors for the main I2C bus, which makes it easy to extend the main bus through the multiplexer or daisy chain several multiplexers one after another. Configure and connect a multiplexer. Once we have selected a multiplexer, we will want to connect it to our DCC-EX command station and then connect our I2C devices to it. However, before we do that, we may want to change the multiplexer's I2C address. As with other I2C devices, I2C multiplexers have an I2C address, and each multiplexer must have its own unique I2C address. The default address for the multiplexers we will look at today is hexadecimal 0x70. If we only plan to use one multiplexer, we won't need to change its address. However, if we want to use more than one multiplexer, we will need to change some of their addresses so that each multiplexer has a different address. We can change the I2C address on our multiplexer the same way we change the I2C address on LCD displays, which we learned how to do in the last video. Depending on the multiplexer, there are either 3 pins or solder pads marked A0, A1, and A2. While the solder pads on the LCD displays subtracted from the default I2C address, on the multiplexer they add to the address. So if we use pin or pad A0, the address will increase by 1. If we use A1, the address will increase by 2. And if we use A2, the address will increase by 4. By using combinations of A0, A1, and A2, we can change the multiplexer's I2C address from the default 0x70 to anything from 0x71 to 0x77. For multiplexers that have solder pads for setting the I2C address, such as the multiplexers with the Stemma Quick connectors, we simply solder across the pads to make the change. For the more typical multiplexer breakout boards that rely on header pins, we jumper the A0, A1, or A2 pins to the I2C, VCC, or VIN voltage line. To do this, we will either need to make our own splitter cable, assuming that we have soldered jumper pins to the multiplexer, or use something like the I2C breakout boards we looked at in the last video. There are also mini breadboards available which might work well for this type of application. Once we have set our I2C multiplexer's I2C address, or decided to use the default address, we are ready to connect the multiplexer to our DCC-EX command station. The multiplexers are compatible with both 5-volt Arduino microcontrollers and 3.3-volt ESP32-based microcontrollers. For multiplexers that have Stemma Quick connectors, we simply connect a suitable Stemma cable to the input port on the multiplexer, which is the connector socket at one end of the board. We then connect the other end of the cable to our DCC-EX command station. If we are using the DCC-EX EX-CSB1 Express, we can use a cable with Stemma Quick plugs on each end, and plug the other end into the stemma quick connector on the EX-CSB1. Otherwise, we can use a cable with a stemma quick plug on one end and female DuPont jumper connectors on the other end and connect them to one of the sets of I2C pins on our command station. Remember that the standard wire colors on the stemma quick cables are black for ground, red for VCC, blue for SDA data, and yellow for SCL clock. For multiplexer breakout boards, assuming that we have soldered jumper pins to them, we will connect them to our command station just like any other I2C device, using jumper cables to connect the VIN, GND, SDA, and SCL pins on the multiplexer to the same pins on our DCC-EX command station's I2C bus. On the multiplexer, these pins are the first 4 pins located on the upper left side of the board and are clearly labeled. Once we have connected the multiplexer to our DCC-EX command station, we are ready to attach our I2C devices, displays in this case, to the multiplexer. Again, the way that we do this depends on whether we are using a multiplexer with stemma quick connectors or a multiplexer breakout board with jumper pins. If we are using a multiplexer with stemma quick connectors, we simply connect a stemma quick cable to our display and plug the stemma quick plug into one of the connector sockets on the multiplexer. Which one we plug into doesn't matter, but we will want to note the number of the connector we used because we will need this later in the video when we configure the EX command station code to use the multiplexer. The stemma quick connector socket number is printed on the board next to the socket. 4-channel multiplexers have sockets numbered from 0 to 3, while on 8-channel multiplexers the sockets are numbered from 0 to 7. For multiplexer breakout boards with jumper pins, we make the connections a little differently. These boards only have individual jumper pins for the SCA data and SCL clock lines. If we look at a typical multiplexer with 8 channels, we will see these are labeled in pairs from SD0 for data and SC0 for clock to SD7 for data and SC7 for clock. So we will connect our I2C displays, SDA data, and SCL clock lines to one pair of these pins. Again, it does not matter which pair of pins on the multiplexer we use, but they must have the same number. So if we connect our SDA line to SD0, we will also need to connect our SCL line to SC0, and so on. However, we will need to connect the display's GND ground and VCC voltage lines to the I2C bus some other way, because there are not individual GND and VCC pins on the multiplexer. Again, we can use an I2C breakout board, a mini breadboard, or make our own splitter cables based on our preference. One other important thing to note about the way that I2C multiplexers function is that they work by temporarily connecting and disconnecting the devices attached to them to the main I2C bus. This allows for multiple devices with the same I2C address connected to different ports on the multiplexer to function independently, because only one device at a time will be connected to the main I2C bus. However, because the multiplexer is still connecting each device to the main I2C bus, even though only intermittently, this means that we still have the restriction that we cannot have any devices on the multiplexer with the same I2C address as any devices connected directly to the I2C bus. So we need to make sure that the main display connected to our DCC-EX command station has a different I2C address from any of the displays we connect to the multiplexer. The easiest way to do this is to change the I2C address of the main display on the command station and then connect our additional displays, all with the default address, to the multiplexer. Once we have connected our displays to the multiplexer and connected the multiplexer to our DCC-EX command station, we are ready to configure the EX command station software to use our new multiplexer and displays. Create our display in DCC-EX. Now that we have connected the I2C multiplexer to our DCC-EX command station, we are ready to configure the EX command station code to use our displays connected to the multiplexer. The DCC-EX EX command station software will work with I2C multiplexers without any modifications. We can verify that our multiplexer and any displays are properly connected to the command station by running EX command station's I2C scanner code by typing open angle bracket D reset close angle bracket on the command line the way that we did in the last video, and then confirming the results. Now all we need to do is create the displays connected to the multiplexer in EX Command Station the same way that we created additional displays in the last video. We can do this in either the myhal.cpp sketch or our myautomation.h sketch in either the Arduino IDE or the EX installer. Again, this is the same process that we used in the last video, so be sure to review that video again if you need or want a refresher. I will also include all the code from today's video in a community post on my channel. For this video, I will demonstrate creating and using the display by editing the myhal.cpp sketch in the Arduino IDE. We will use the myhal.cpp sketch again later in this video to add another function to show additional information about our locomotives. We could just as easily edit the sketch in EX installer, but I find the code easier to read in the Arduino IDE. To create a display connected to the multiplexer in EX Command Station, we add a line of code in the HAL setup function in the myhal.cpp sketch, the same way we did in the last video. We will need the following information about our display: whether it is an LCD or OLED display, its resolution, its I2C address, and which port it is connected to on the multiplexer. Remember, we can confirm the I2C address and the multiplexer port in the I2C scanner. We will also need to decide what screen number we want to assign it from 1 to 242. The code to create the display has the following syntax: HAL display, open angle bracket, OLED or liquid crystal, close angle bracket, create, open parenthesis, our desired screen number, comma, open curly bracket, subbus underscore, which multiplexer port, comma, the display's I2C address, close curly bracket, comma, and the display resolution, close parenthesis, semicolon. So, for a 20x4 LCD display with I2C address 0x27 connected to multiplexer port 1 that we want to be screen 1, we would type HAL display, open angle bracket, liquid crystal, close angle bracket, create, open parenthesis, 1, comma, open curly bracket, subbus underscore 1, comma, 0x27, close curly bracket, comma, 20, comma, 4, close parenthesis, semicolon. For an OLED display with I2C address 0x3D and a resolution of 132 by 64 connected to multiplexer port 3 that we want to be screen number 2, we would type HAL display, open angle bracket, OLED, close angle bracket, create, open parenthesis, 2, comma, open curly bracket, subbus underscore 3, comma, 0x3D, close curly bracket, comma, 132, comma, 64, close parenthesis, semicolon. If we are only using one I2C multiplexer, then that's all there is to it. If we are using more than one multiplexer, we also need to specify which multiplexer our display is attached to by adding I2C mux underscore with the multiplexer number before the subbus. So we would modify our code as shown here, with the multiplexer number being based on its I2C address, 0 for 0x70, 1 for 0x71, etc. Again, we can confirm all this by running the I2C scanner code in EX Command Station. Finally, as I indicated before, we can create our displays in either the myhal.cpp sketch or the myautomation.h sketch. The code syntax is slightly different if we create the display in myautomation.h. We start the line with HAL parenthesis and then eliminate the create parenthesis and replace it with a comma. We also eliminate the semicolon at the end of the line. The resulting line of code would look like what is shown here. Use our new display. We can use any displays connected to the multiplexer the exact same way that we use displays connected to the main I2C bus, which is by using the DCC-EX screen command, just like we did in the last video. As a reminder, there are two ways we can use the screen command: in our EXRail scripts in myautomation.h and other automations, and in the EX command station code in myhal.cpp or other sketches. In the last video, we added a function in the myhal.cpp sketch to display information about our active locomotives. Now let's add a new function to display information about our locomotive's active decoder functions. We can create a function to do this in the myhal.cpp sketch, but if we want to know which is the current locomotive at any given point in time, we will need to make 3 small edits to the EX command station code. Unfortunately, we can't do this in EX-Installer, which means we will need to use the Arduino IDE. If we don't want to use the IDE, we can still show the information for one locomotive just by editing the myhal.cpp sketch in EX-Installer. I will include all the code for both versions of the functions in a community post on my channel. We have now learned how to add additional displays, including multiple displays with the same I2C address, to our DCC-EX command station by using an I2C multiplexer. With up to 8 multiplexers and 8 or more displays attached to each, we could conceivably add dozens of additional displays to our command station. As a practical matter, we will probably want to limit the number to a handful or so, because eventually we would need to find a separate power supply to light up all those displays and modify the pull-up resistance on the I2C bus. Nevertheless, we now have several different ways to display even more information from DCC-EX on our layouts, and how we use all those new displays is only up to our imaginations. What's next? Assemble a WiTController for DCC-EX. This video wraps up the series on DCC-EX in 2025. During the series, we looked at the new EX-CSB1 Express all-in-one plug-and-play command station and booster. We learned how to use the EX-Installer and the Arduino IDE to configure our DCC-EX command station and add new functions to the command station using the myhal.cpp sketch. We learned how to customize the display of our command station, added a second display to the command station, and then learned how to add more displays using I2C multiplexers. Finally, we looked at 2 DIY alternatives to the EX-CSB1. In my next video, we'll look at how to assemble a WiTController, handheld controller and throttle to use with DCC-EX to control our trains. Be sure to subscribe to the channel so you don't miss any upcoming videos, and check this video's description for links to my other videos, including my video series on assembling a DCC-EX command station and my series on using JMRI's Decoder Pro app to control our trains. The year is half over, but that means the second half is just beginning. There are places to go and things to see, so hop on board and let's find out together what lies on the tracks ahead. Until then, thanks for watching. Well, Scratchy, are you ready for our next run? Then let's go find our train. All aboard!